And the thing I want to do next is say, let's just deal with a single row at a time. So let's not worry about the rest of the row. Let's not worry about going in columns. Just deal with one row, but also have that row handle the cross letters, the cross words. So I'm going to need a representation for a row, and I think I'm going to make that be a list. There are many possible choices, but a list is good. I choose a list rather than a tuple because I want to be able to change it in place. I want to be able to modify the row as we go, as the game evolves. So row is going to be a list of squares. If a square is a letter, we'll just use that letter as the value of the square. If the square is an empty spot, which has nothing in it, I think I'll use dot just to say nothing is there. Trick that you learn once you've done this kind of thing a lot of times is to say, well, you know what? I'm going to be looking at letters. I'm going to be looking at locations in the row. I'm going to be looking at their adjacent letters and going to the right and going to the left. So if I'm trying to fill in from this anchor, I'll move to the left to put in the prefix, and I'll move to the right to extend the word. And it seems to me like I'm always going to have to be making checks of saying, what's the next character? Is it a letter? Is it an anchor? What is it? And also, oops, did I get past the end of the board? It seems like I'm going to have to duplicate the amount of code I have to write to check both the case when I go off the board and when I don't go off the board. So one way to avoid that is to make sure you never go off the board. Cuts the amount of code in half to some extent. A way to do that is to put in extra squares. To say, here are the squares on the board, but let's make another extra square on each side and just fill that in to say the value of this square, what's in that square, is a border, not a real square that you can play in. But if I'm here and I say, what's the value of square number I minus 1, I get an answer saying it's a border rather than getting an answer that's saying when you go I minus 1 from position 0, you get an error. And I think I'll use a vertical bar to indicate a border. So I'll have one there, and at the end of my row, I'll have another border. So now I sort of got everything. I've got borders, letters, empty squares. The only thing left is anchors. And I think what I'll do here is I'll introduce a special type for anchor. I could have used something like a tuple or a set of characters, but I want to make sure I know, and I want to have something in my code that says if the value of row sub I is an instance of anchor, then I want to do something. And so we'll make anchor be a class, and I want it to be a class that contains a set of letters. And I can do that in a very easy way. I can use a class statement to say I'm going to define a new class. The class is called an anchor, and the class is a subset of the set class. And then I don't need anything else for the definition of the class. All I have to know is that anchors are a type of set, but they're a particular type of set. They're a set of anchor letters. So here's a code for that. I define the class of anchor. I have all of my allowable letters. Then I say any is an anchor, which allows you to put any letter onto that anchor spot. And now I want to represent this row where here are the borders, here are the empty spots, and here are the particular letters. And this representation, the schematic representation as a string, does not account for a fact that after the A, we're going to have two restricted anchors that have to contain these characters. So we'll define them. Use the names MNX and MOAB to be the two anchors that are restricted to have only those letters. And now our row is equal to the border square is element number 0, and then the A is element number 1. Then we have these two restricted anchors, two more empty spots, another anchor where anything can go, the B and the E, and so on.